This is an audiovisual presentation on statistics 2, and this is continuation of statistics 1. Now here we will consider the cumulative frequency tables. Now considering the table given, we have max in percentage against the frequency. So 1 to 10 is 0. 11 to 20, that is those who had from 11 to 20 max, is 2. 21 to 30 is 6. 7 people had 31 to 40. 14 had 41 to 50. 20 had 51 to 60. 35 had 61 to 70. 29 had 71 to 80. 6 had 81 to 90. And 1 person had 91 to 100. Now we are supposed to make a frequency distribution table. Now this is the table. We have max in percentage as was given in the previous table. We have the frequency, their corresponding frequencies, and these are the max less than. How do you generate the max less than? That is what I'm going to show you now. We first have to find the class boundaries. How do we find, or how do we generate the class boundaries? Now let's consider the interval from 1 to 10. The lower limit is 1 and the upper limit is 10. The next interval, the lower limit is 11 and the upper limit is 20. Now let's consider these two intervals. The upper limit of the first interval is 10 and the lower limit of the next interval is 11. So the difference between the lower limit, the difference between the upper limit of the interval and the lower limit of the next interval divided by 2 will give us the 0.5. Now let me show you this. The upper limit of the interval 1 to 10 is 10, and the lower limit, that is the next interval, the lower limit of the interval 11 to 20 is 11. So the difference between 11 and 10 is 1. When we divide 1 by 2, we have 0.5. So if you want to find the max less than, that is the upper class boundaries, we add the 0.5 to the upper limit. So 10 plus 0.5 will give us 10.5. 20 plus 0.5 will give us 20.5. 30 plus 0.5 will give us 30.5. 40 plus 0.5 will give us 50.5. So in order, we have 50.5, 60.5, 70.5, 80.5, 90.5, and 100.5. So these are our max less than. Now, how do we generate the cumulative frequency? It's very important. Take note that considering the first interval 1 to 10, the frequency was 0. So starting, the cumulative frequency is also 0. Now take note, 2 plus 0, that is 2, the second frequency plus the initial cumulative frequency. So 2 plus 0 will give us 2. 6 plus 2 will give us 8. 7 plus 8 will give us 15. 14 plus 15 will give us 29. 20 plus 29 will give us 49. 35 plus 49 will give us 84. 29 plus 84 will give us 113. 6 plus 113 will give us 119. And 1 plus 119 will give us 120. So that is how we generate the cumulative frequency column. Let me go over this again because it's very important. That's what we are going to use in drawing the cumulative frequency curves. We said that the frequency for the interval 1 to 10 is 0. So the cumulative frequency also starts from 0. Then we now begin to add downwards. So we add 2 to the initial cumulative frequency. So 2 plus 0 will give us 2. 6 plus 2 will give us 8. 7 plus 8 will give us 15. 14 plus 15 will give us 29. 20 plus 29 will give us 49. 35 plus 49 will give us 84. 29 plus 84 will give us 113. 6 plus 130 will give us 119. And 1 plus 119 will give us 120. So the total cumulative frequency is 120. Now let's proceed. This is an example of the cumulative frequency diagram. We have a graph of cumulative frequency against the values. When you plot the cumulative frequency against the max less than, this is the shape that you are going to form. This is the shape that you are going to form. This is the shape that is going to come out. Now let's look at this example. The lives of 80 circuit components were recorded in hours to the nearest hour and grouped as follows. We have life in hours and the frequency. 660 to 669, the frequency is 3. 670 to 679, the frequency is 7. 680 to 689, the frequency is 10. 690 to 699, the frequency is 15. 700 to 709 is 24. 710 to 719 is 12. 720 to 729 is 5. And 730 to 739 is 4. Now, this is the table that we are given. Now, make a cumulative frequency table and use it to draw the cumulative frequency curve. Make a cumulative frequency table and use it to draw a cumulative frequency curve. So now, this is our table. Now, there is something I want to show you here. Take note, we have life in years, we have the frequency, the lives less than, and we have the cumulative frequency. Take note that from the table given previously, the interval started from 660 to 669. But I added an interval, a previous interval, that is from 650 to 659. If you like, you can start from where you were given. Why did I add this interval before the 660 to 669? It is because the frequency for 660 to 669 started from 3. That means that you have to start from 3. But if you start from 0, then it means you will start from the origin, which you can see. However, you can also start from 3. When we get to the curve, you understand what I mean by this. So starting from creating my own interval before the starting interval, that is 660 to 669. From 650 to 659, the frequency is 0 because I created it myself. The lives less than, when you add the 0.5 to 659, you get 659.5. And I guess by now you know how we had the 0.5. The cumulative frequency is 0 because the frequency is 0. Now, we now start. Take note, if you want the lives less than, you add 0.5 to the upper limit. So 669 plus 0.5 is 669.5. 679.5. 679 plus 0.5 is 679.5. 689 plus 0.5 is 689.5. So in that order, you have 699.5, 709.5, 719.5, 729.5, and 739.5. That is the lives less than. So we start with the cumulative frequency. Initially, we have 0 because the frequency here is 0. Take note that if you start from the interval 660 to 669, your initial cumulative frequency will not be 0. It will rather be 3. It will rather be 3. But now that we have generated our own interval before the starting interval, that is why the cumulative frequency is starting from 0. That means that from your graph, you can start from the origin. Now, 3 plus 0 will give us 3. 7 plus 3 will give us 10. 10 plus 10 will give us 20. 15 plus 20 will give us 35. 24 plus 35 will give us 59. 12 plus 59 will give us 71. 5 plus 71 will give us 76. And 4 plus 76 will give us 80. So the total cumulative frequency is 80 here. Now, this is the graph of cumulative frequency against the life in hours. Against the life in hours. Take note that we added the interval 659 with a frequency of 0. And that is why it is starting on the x-axis. If you were supposed to start from 3, it means it would have been a little higher than where the point is. However, it is still the same. You will get the same thing. So now 659 has frequency of 0. So this is our point. The next point will be 669.5 and 3. So 669.5 and 3. This is our point. The next is 679.5 and 10. So 679.5 and 10. This is our point. 689.5, 20. So 689.5 and 20. This is our point. 699.5, 35. We have 699.5 and 35. 709.5 against 59. So 709.5 against 59. 719.5 against 71. So 719.5 against 71. 729.5 against 76. So 729.5 against 76. Then 739.5 against 80. So 739.5 against 80. So we are done with locating the point on the graph, and we now joined the points together freehandly. We do a freehand joining of the points, and that is what we have. This is the cumulative frequency diagram. This is the cumulative frequency diagram. Now, assuming we are supposed to find median from a cumulative frequency, take note that the total cumulative frequency gave us 80. If you want to find the median, what you have to do is to take half of sigma f, and summation of the cumulative frequency we had 80. So half of 80 will give us 40, and that is why we have 40 here. So we trace 40 till where we touch the cumulative frequency curve. Then we trace it vertically downwards to the x-axis, and we read the value on the x-axis. Now from this graph, the value is 701.5. That means that the median from the cumulative frequency curve is 701.5. I repeat, you only take half of the summation of the cumulative frequency, then you locate it on the y-axis. That's the cumulative frequency axis. You trace it till you touch the curve, then you trace it vertically downwards, and you read the point into 701.5. Now we have quartiles from cumulative frequency curve. Considering the cumulative frequency curve, we have cumulative frequency against the life in hours. Now 1/4, when we take 1/4 of sigma f and we trace it to the x, we have Q1. The Q1 is the lower quartile. When we take half of sigma f and trace it to the x-axis, we have Q2. That is the second quartile, which is the median. And when we take 3/4 sigma f and we trace it also to the x-axis, we have Q3. That is the upper quartile. Now the interquartile range is equal to Q3 minus Q1, where Q1 is the lower quartile and Q3 is the upper quartile. So when we subtract the lower quartile from the upper quartile, we have what we call the interquartile range. Now the semi-interquartile range is half of Q3 minus Q1. That is half of upper quartile minus lower quartile. Now we have measures of dispersion, the range. We have what you call the range. Now let's consider this set of numbers: 33, 35, 45, 11, 12. The least value equals 11, as can be seen, and the greatest value equals 45, as can also be seen. If you want to find the range, it is the greatest value minus the least value. So 45 minus 11, the answer is 34. That means that the range is equal to 34. Now we have mean deviation. Mean deviation of a set of numbers. The mean deviation is given by the magnitude of x minus x bar divided by n, where x bar is the mean, and the mean is given by summation x. That's the total x values divided by n. Example: find the mean deviation of the set of numbers 11, 12, 13, 14, and 15. So we first have to find the mean first, and the mean is summation of the x values, divided by the total. So we sum them. We have 11 plus 12 plus 13 plus 14 plus 15 divided by 5. That is the number of occurrence of the numbers. We have 1, 2, 3, 4, 5. So we divide it by 5. Now this is equal to 65 divided by 5, and the answer is 13. That means that the mean x bar is equal to 13. So we have this table. The x values, we have 11, 12, 13, 14, and 15. Now x minus x bar. The magnitude means that when you get negative, you take the magnitude and the answer gives you positive. The x bar gave us 13. So x minus x bar means that when you take an x value, you subtract the mean from it. So 11 minus 13 will give us minus 2. But the magnitude of minus 2 is 2. 12 minus 13 is minus 1. The magnitude is 1. 13 minus 13 is 0. The magnitude is 0. The magnitude is 0. 14 minus 13 is 1. 15 minus 13 is 2. Now, we have to find summation of x minus x bar. So 2 plus 1 plus 0 plus 1 plus 2. The answer is 6. So we have x bar to be 13. Now, the mean deviation will be equal to the summation of x minus x bar divided by the n. And this is equal to 6 divided by 5. And 6 divided by 5 is equal to 1.2. So the mean deviation of the set of numbers that was given in the question is equal to 1.2. Now we have mean deviation from a frequency distribution table. And the mean deviation is given by summation of f x minus x bar divided by summation of f, where the x bar, the mean, will be equal to summation of fx divided by summation of f. Now let's look at this question. Calculate the mean deviation from the mean of the distribution below. We have the class and the frequency. So 10 to 15, the frequency is 2. 10 to 20, 12. 20 to 25, the frequency is 27. 25 to 30 is 41. 30 to 35 is 30. And 35 to 40 is 7. Now you are supposed to calculate the mean deviation from the mean of the distribution below. So in tabular form, we have life in years as was given, frequency as was given in the question. Since we want the summation of f, we have to add the frequency. So 2 plus 12 plus 27 plus 41 plus 30 plus 7 will give us summation of f, and that is 119. Now we have the class midpoint. How do we find the class midpoint? The class midpoint is the x. So how do we find the class midpoint? We add the lower limit to the upper limit and divide the answer by 2. Example, 10 plus 15 is 25. And when we divide 25 by 2, we have 12.5. 15 plus 20 will give us 35. When we divide 35 by 2, we have 17.5. So I advise you to continue as you have the values 22.5, 27.5, 32.5, and 37.5. You can pause where you have to pause and do the calculation so you can understand it better for yourself. Now, fx means we are multiplying the frequency by the class midpoint. So 2 times 2.5 is 25. 12 times 17.5 is 210. 27 times 22.5 is 607.5. 41 times 27.5 equals 1127.5. 30 times 32.5 is 975. 7 times 37.5 is 262.5. And so we also have to find the summation of fx. And so 25 plus 210 plus 607.5 plus 1125.5 plus 975 plus 262.5. And the answer is 3207.5. So now our mean is equal to summation fx divided by summation f. Summation fx give us 3207.5 divided by summation f give us 1119. Give us 119. Take note, I repeat, x bar is equal to summation fx divided by summation f. Summation fx give us 3207.5 and summation f give us 119. So 3207.5 divided by 119 is equal to 26.95. That means that the mean is 26 26.95. Now we come to this table. You look at this table, you have the class interval, we have the frequency with the summation of frequency to be 119. Don't forget the mean gave us 26.95. The class midpoint, we now know how to generate them by adding the lower limit to the upper limit and dividing your answer by 2. Now x minus x bar. When we take each class midpoint value, we subtract the mean from it and take the magnitude of it. That means that if we get a negative answer, the magnitude of that gives us a positive answer. Now x minus x bar. So now we first take the first class midpoint value. So 12.5 minus 26.95. The answer is minus 14.45, but because of the magnitude, the answer is positive, so we have 14.45. 17.5 minus 26.95 is equal to minus 9.45. And when you take the magnitude, you have 9.45. So it means you have to write the positive answers. Next, we have 22.5 minus 26.95. It's also negative, but if you take the magnitude, you get 4.45. 27.5 minus 26.95 will give you 0.55, and this is positive. 32.5 minus 26.95 will give you 5.55. 37.5 minus 26.95 will give you 10.55. And that is how we generate the x minus x bar values. Now we multiply f by the x minus x bar. So we have 2 times 14.45, and that is 28.90. Then we have 12 times 9.45, we have 113.40. 27 times 4.45, and we have 120.5. 41 times 0.55, we have 22.55. 30 times 5.55, we have 166.50. And 7 times 10.55, we have 73.85. Now we also sum. So 28.90 plus 113.40 plus 120.15 plus 22.55 plus 166.50 plus 73.85 is equal to 525.35. So we have summation of f times s minus s bar. We had 525.35, and summation of f is equal to 119. So the mean deviation is equal to summation f times x minus x bar divided by summation f, and that is 525.35 divided by 119, and the answer is 4.41 corrected to 2 decimal places. 4.41 corrected to 2 decimal places. That is the mean deviation from the frequency table. Now we have what we call the standard deviation. We have the standard deviation of a set of numbers, and is given by s equals the root of 1 over n, summation of x minus x bar all square, where the x bar is the mean. That is summation of x over n. Now let's take an example and see how best we can solve the example. Okay, before the example, let's look at the standard deviation also from the frequency distribution table. We have the ungrouped data, and for the ungrouped data, the standard deviation is the overall root of summation fx square over summation f minus the mean square, where the mean is equal to summation fx divided by summation f. That's for the ungrouped data. Now for the grouped data, we use the assume mean method. That is x bar is equal to a plus summation fd divided by summation f. So x is equal to summation fd square divided by summation f minus summation fd divided by summation f all square. This is the formula we use in calculating the standard deviation using the assume mean method. So where di is the deviation, that is xi minus a, where xi are the class midpoint values from the table, where xi are the class midpoint values, and d is the deviation. Now we have variance. Variance is the square of the standard deviation. So after calculating the standard deviation, when you square your answer, whatever you are getting, we call it the variance. That is all. Now example, find the standard deviation and the variance of the set of numbers 11, 12, 13, 14, 15. These are the numbers. Now let's look at the method 1. First, we have to find the mean. That's x bar. And there is summation x over n. So we have 11 plus 12 plus 13 plus 14 plus 15 divided by 1, 2, 3, 4, 5. So we divide it by 5. And we have 65 divided by 5. And the answer is 13. So the mean of the set of numbers given in the question is 13. Now we proceed. From the table, we have the x values. Then we have x minus x bar. So we have 11 minus 13, that is minus 2. We have 12 minus 13, that is minus 1. 13 minus 13, that is 0. We have 14 minus 13, that is 1. 15 minus 13, the answer is 2. Then we have x minus x bar square. It means we have to square all these values. Minus 2 square is 4. Minus 1 square is 1. 0 square is 0. 1 square is 1 and 2 square is 4. Now we have to find the summation of x minus x bar square. So 4 plus 1 plus 1 plus 4 is equal to 10. So summation x minus x bar all square is equal to 10 and n is equal to 5. So from the standard deviation formula, we have s is equal to 1 over n summation of x minus x bar all square, and n is 5, and summation of x minus x bar all square has given us 10. So by substitution, we have s equals the square root of 1 over 5 times 10. And 5 goes into 10 2 times. So we have the square root of 2, and that is 1.41. Now we said that the variance is the square of the standard deviation. So if the standard deviation is root 2, then it means that when we square the root 2, the 2 cancels the square root and we are left with 2. So the variance is 2 and the standard deviation is root 2, which is the same as 1.41. Now let's look at the method 2. With the method 2, we still find the mean as in the method 1. The mean is equal to summation x over n, and that gives us 13. After calculating the mean as shown, we have 13. Now we have this table. We have x and x squared. These are the x values. We have 11, 12, 13, 14, 15. Now when we square 11, we have 121. When we square 12, we have 144. 13 square, 169. 14 square, 196. 15 square, 225. Now take note that the 15 square is 225. Please, summation of x squared. When we sum all these values, we have 855. I advise you to sit down, take your time, and do it one by one to see that whatever you are doing is correct. It's very important. Summation of x squared is equal to 855. That is when you sum all the x squared values. The x squared values are gotten by squaring all the x values. That is all. So summation x squared equals 855 and n is equal to 5. So s is equal to summation x squared over n minus mean squared. So we have 855 divided by 5 minus 13 squared. 855 divided by 5 is equal to 171 minus 13 squared is equal to 169. So s is equal to the square root of 2. And the square root of 2 is equal to 1.41. So you realize that we are getting the same answer as we had when we used the method 1. Now let's look at the mode from a histogram. Assuming we are given this histogram, how do we find the mode? First, we have to select the tallest bar, and we can see that this is the tallest bar. After selecting the tallest bar, you select the bars on the left and on the right of the tallest bar, and these are the bars we have. We now draw a line from this corner of the tallest bar to this corner. Then you also draw a line from this corner also to this corner. Where the two lines meet, we draw a vertical line to meet the x-axis. We draw a vertical line to meet the x-axis. The value on the x-axis is the mode from the histogram. is the mode from the histogram. This is the end of our presentation.